So welcome everybody, and thank you so much for joining us today at our webinar. To begin, I'd like to acknowledge the traditional custodians of the lands on which we meet and pay my respects to elders past, present and emerging. I extend that respect to Aboriginal and Torres Strait Islander people joining us today. So if you haven't met me before, my name is Kirsty Miller. I'm Head of Strategy and Growth at DIAS, and it's a pleasure to host today's session on modernisation. For those of you who already know us at DIAS, hello again. And for those of you who are new, a quick introduction about who we are and what we do. We're a technology consulting company that builds custom software and hardware solutions for clients. We have a unique and broad skill set that spans data, devices, digital design, and AI, which makes us the perfect choice for clients who are looking to build intelligent products. At our webinar today, we welcome questions. Please go ahead and ask them via Slido. There's the QR code or the details on the slide, and I'm pretty sure that we'll be popping that link into the chat document as well, so that you can ask them. So, who are we hearing from today? Well, we're going to be hearing from three of our most experienced and senior principal consultants, Eric Danielson, Matt Kerries, and Dan Lavolsi. They'll be giving you a bit more information about their experience and their areas of expertise at the start of each of their presentations. So, as we look forward to 2025, the need for modernisation has never been more pressing. So we hear that from our clients. They consistently tell us they're navigating a fine balance. So there's this race to adopt cutting-edge technologies like generative AI, while grappling with foundational issues that can slow progress and derail innovation. So modernisation is no longer a nice to have, it's essential. And time again, we're hearing the same concerns. So how do we keep innovating without spiraling costs? What's holding us back from getting real value from new technology? And are our teams equipped to deliver at the pace the business needs? So these challenges make modernisation a priority right now. And through our work with organisations across many industries, we found that tackling three critical areas: tech debt, cloud optimization, cloud cost optimization, and high-performing teams can help businesses build the foundation they need to move forward confidently. So tech debt, it's one of those pervasive issues. It's like rust accumulating beneath the ship's hull. You know, technical debt often starts as a very unseen burden, but over time it grows and it makes it really hard to navigate forward. High-performing teams. I like to say that the holy grail for any organisation with a digital platform is a high-performing team. They determine what you can deliver and how effectively you can get things done. So this is so important when you need to balance legacy systems improvement and innovation. And then lastly, cloud cost optimization. So staying with a budget is always important, but it's particularly now, we need to free up resources for strategic initiatives and new technology adoption. An area like generative AI, large language models in particular, is so easy to overinvest in without the proper understanding of cost drivers. Are these the only areas organizations should be addressing? Of course, this depends on their individual situations. But what we do know is that these areas aren't just technical problems. They're actually deeply interconnected challenges that, when addressed, they drive significant business benefits. So there's a lot of synergy between these three areas. So excessive tech debt creates frustration and reduces productivity, but reducing it allows teams to focus on innovation and future growth. High-performing teams are equipped to address tech debt systematically. So this creates a cycle of continuous improvement and adaptability. And empowering teams to manage cloud resources efficiently ensures financial accountability, as well as fostering agility and innovation. So we've made these pillars the focus of today's session because they have an outsized impact on an organization's ability to innovate and thrive. You'll hear from Matt, Eric, and Dan with some practical insights and real-world examples of how organizations have tackled these challenges head-on. And by the end of this session, it's our aim to provide you with some actionable strategies to align your team, infrastructure, and budget, enabling you to modernize with confidence and resilience. So I'm going to hand over to Eric Danielson, who's going to start now, and he's going to be talking about technical debt. Thanks, Eric.
Hello. So yeah, my name's Eric. I've been with DS for about 16 years. Started out mostly as a developer, but more recent years I've been more in sort of technical leadership positions, less and less hands-on, and more just helping teams and organizations with leadership and with advice. I would say that over time, it's maybe interesting, even though from a technical background, I'm less and less interested in the technical detail and technology itself, and more interested in the business problems that we help people solve, because at the end of the day, technology is there for a reason. So if we jump to the next one, we'll talk a little bit about technical debt. So for me, technical debt, there's a couple of different ways to categorize it, and we probably all have a reasonable understanding of what it means. But for me, maybe the first one to talk to is entropy. No matter how well you do as an organization, it's really hard to avoid that things deteriorate over time. So I don't think I've ever seen a team or an organization that actually makes things better over time. That would be amazing. That's not because you're trying to make it so. It's just that as you make changes, you are likely to do things that the original design weren't built for. So you design something up front to solve the initial problem, and then you have new features added on, and you have new features added on over time, and they don't necessarily neatly fit in. And as a result, your application just tends to be suffering from that, basically. Sometimes that's because you take a shortcut, say because of a deadline, and that might just be that you're making a non-optimal decision on how you implement something. Sometimes it is just that, like I said, it didn't quite naturally fit in. All the things to be worth talking about would be catching up on lack of maintenance. So that would be things like security patching, upgrading of third-party dependencies, operating systems, whatever they might be. That's also, I would say, tech debt in some form. And I would say that the cause of technical debt, and I think Dan's going to touch on this a little bit more, it could be caused by poor engineering decisions. It's not necessarily. It's often that the team is put under pressure as well to deliver fast. But certainly could say that if you have an inexperienced team or a lot of inexperienced people, you are more likely to suffer from it, because they are less likely to push back and they are less likely to make good decisions on the fly. Jump to the next one. Why is it a problem? Well, the main problem with it is that new feature development becomes more expensive. And that's sort of the main reason why we want to deal with it. If you notice that you're adding new features just seem to take longer and longer as you go, then one of the reasons for this could become that the state of the application, the state of the code base is such that it's difficult to make changes. We see that quite a lot. You also see that maintenance costs keep rising because you spend more and more time on, say, incidents or on unplanned work, basically. So things that you don't often account for. So if you're looking at things, and then might talk about again, you're talking about measuring how quickly the team can deliver. Well, if they're slower and slower, they're spending more and more time on things that were not in your original plan. That's also a symptom. It might be one of the reasons for that. And then you have staff. Very few people enjoy working with a system that's in a poor state. Most people like working with new technology, being able to be productive. So most people enjoy being productive. And so you are more likely to lose your stuff, and hiring also becomes difficult. So we've seen this, like I can see that I've seen it very recently because we've got outdated technology in a current client I work with. Finding people who want to work with it is one thing, finding people who are able to work with it is another, because it's outdated. Say newly educated engineers they've never come across this technology before. So you're looking at more expensive contractors, that's the thing, it becomes a problem. And yeah, why do we address it then? Well, if we want to be able to deliver faster, be more productive, we want to have to look at what we can do to reduce the impact of technical debt. Go to the next one. So, is it always a problem? Well, I would say it's a problem, but did this happen as part of a conscious decision, or did it happen just because? Yeah. Was it clear to everyone that the trade-off was made at the time where, say, you made an suboptimal decision? Well, that's the question. So, for instance, sometimes a business is under pressure to deliver. Say you're a startup and you really just have to get something to market. In that case, you have to make a short-term decision, but it's a conscious decision. As long as you know that and everyone's under understanding that you'll have to pay this back later, it might be fine. You have existential crisis scenarios. I had a client not too long ago which were in that situation where they'd already sold something that was not built yet, and so as a result, we had to try to scramble to get it delivered. They had no choice because they were in danger of going out of business. So that in that case, you didn't really have time to think too hard about every decision. You're just doing what you can with the time you have. Budgetary constraints similarly. I think the key message is that the decisions should be conscious and the consequences or the trade-offs need to be communicated. That's the main thing. Yeah. Communication, the previous slide, please. Yeah. So communicating and showing people that there's a problem, that is the key thing here. Engineers aren't always the best people to do it because they tend to focus on technical sort of detail, which may not be understood well by non-technical stakeholders. But what usually works is data that you can help back up a problem, like when you're trying to explain it to someone. So there are many different types of metrics that can be used. I would say some of them are more technical, like you can actually, there are products like SonarQube, which let you analyze the code base. And if you use the tool over time, it will sort of track trends of whether your code base is in a better or worse shape. It will tell you things like the test coverage, which is an obvious one, so automated test coverage, but also the complexity, can measure the complexity of a code base. And a code base that is highly complex is difficult to make changes to, is risky to make changes to. You're more likely to introduce defects. And you can also do other things. There's many, many metrics. But for me, like the main ones I look for is called cyclometric complexity, which is really that how complex is the code base. Also, how big is each individual file class, because it says something about it. It wasn't split up very well, it's harder to maintain, and the test coverage, because that tells me something about how safe it is to make changes. Then we have other things like outdated libraries and dependencies. If you fault, so the IT world moves very fast, and in some languages, some technologies are worse than others, like JavaScript. It moves so fast that what you just started using might be outdated in just months or within a year. And so if you don't keep up to date or try to upgrade the third-party open source or paid even libraries that you're using in your code, it becomes a really hard one to overcome later. For instance, now I'm working with a client where they've had libraries or dependencies that they haven't updated for years, and they can't even go to the latest version because there's no direct upgrade path. So they have to go and do this bit by bit, and that takes even longer. So the effort now to upgrade is massive. And why would you want to do it? Well, things like security vulnerabilities are introduced in an older dependency. You just have no choice but to upgrade, or you need new features that are not supported in an old version. Trends. So if you use tools like ServiceNow or something else, for instance, to track organizational incidents, or if you're doing it by any means. It could be a spreadsheet for that matter, but being able to track them is quite important. If you haven't got them tracked, maybe you can use anecdotal information you have elsewhere, like the previous client just went through all Slack channels to find out when things went wrong in a production system, just started making a logbook of that after the fact, classify them as what type of problem was it, and see, basically plot them on a timeline to see, okay, is things getting better or worse? Can we see, we sort of feel something is wrong, but can we prove that it's getting worse? Similarly for defects, like users usually feel it, even if you don't have a number for it, the users will feel whether things are getting better or worse. But if you also have the data to back it up, you have another sort of data point there to say, yeah, it is definitely getting worse. Time to do something. Cycle time is a completely different one. It's a non-technical metric. It's got more to do with how long it takes teams to deliver. And Dan again might be touching on some of this, but this is the time it takes from you pick up a new piece of work till it's releasable or released. And if that also starts ballooning up, then you know that something's not quite right. And as we mentioned already, the staff turnover that's very costly, because bringing someone new up to speed on, say, a bigger system takes a long time. And that means that they're not going to be as productive. And for a longer period of time, you will deliver less work. So maintaining staff, and especially staff that has a lot of knowledge, is important. So key strategies, well, there's a few. Like I mentioned, tracking metrics is really key. If you haven't done it from the beginning, you can always introduce it later, like these tools like SonarQube. It's just an example, but most languages have their own tools that you can use. .NET has, Java has, Ruby has, JavaScript has, different tools that are free that you can use to sort of measure the quality or the status of a code base. And then budgeting. So when you're doing your roadmap and planning, setting off a certain amount of effort that can be used for addressing technical debt. And so it's explicit in a plan and not something that you just try to squeeze in when you can, if you really want to make inroads into it. And as you mentioned, decisions need to be deliberate so that you don't hide it when you take shortcuts. It's important that it's communicated and that someone else has to then accept that when they make a decision, there might be some consequences out of the decision, and they also have to accept them. You're just a messenger in that case. But yeah, important to set a message. And I'll hand over to Dan, who's going to talk about high-performing teams.
Yeah, thanks, Eric. So my name is Dan Lavolsi, and I've been working with managing software development teams for well over 15 years now. So my background is in product management and delivery. So I'm always looking to drive outcomes and really focused on building the right thing. So this is a topic that's quite close to my heart. I'm really passionate about building and working with high performance teams because I know what great things you can do with them. In context of modernization and kind of building on what Kirsty mentioned, I believe that high performance teams is a key component in the ability to innovate. And that's fundamental in any modernization journey. So as I was preparing for, next slide, please. As I was preparing for this talk, it got me thinking about sometimes I've worked with teams that maybe weren't so high performing. You could say they were low performing teams. And it reminded me of a time when I joined a team and it was pretty clear early on that they were struggling. They'd often miss deadlines. They had a really good tech lead. He was trying to bring dev practice changes like unit testing and more automation, but that was really being met with a lot of resistance from the devs in the team. So I'm very resistant to change. And there was just generally low trust, poor communication, and the team just wanted to work in their own little silos. They weren't too interested. So there was no real shared accountability as a team itself. So the impact was pretty clear. What I noticed was a lot of bugs in that system, with regular production incidents, and they were particularly painful to deal with. And software production releases were a bit of a nightmare, and it kind of reminded me of a time when I've been with the team for a few months and we did a lot of testing. Unfortunately, a lot of it was manual, but we're confident in the release. It was an out-of-hours release. We started the deployment and then quickly we realized that there was an issue. And what the problem was that the our test environments and production environments had drifted apart. They weren't in sync anymore. So a lot of the testing we'd done was not valid. So there's no infrastructure as code and sort of these good practices that we had that you could replicate environments more quickly. And needless to say, that was a chaotic nightmare of a release, very stressful, and last minute fixes at 3 a.m. in the morning, which I definitely don't recommend. But as a result of all these things that I observed, I would say the morale in the team was pretty low. And what's more, our stakeholders were quite frustrated because they didn't feel like they were getting what they needed and the quality just wasn't there. So that experience really highlighted to me the importance of having a high-performing team in order to be successful. So why are high-performing teams important? So we know that they're more productive and efficient. In fact, Deloitte did a study and they found that organizations with high employee engagement report up to 21% higher productivity than their less engaged counterparts. What's more, we know that team members have a higher job satisfaction and there's low turnover rates, sort of following on to Eric's point. There's also a study to back this, and it was done by Gallup, State of American Workplace Report, which you imagine would correlate pretty closely to what we have here in Australia. And they found that high-performing teams experienced up to 59% lower turnover rates. And so sort of some of the points that Eric mentioned, the cost of replacing people is significant. It's not something we're doing regularly. So that's a pretty astounding figure. We know that high-performing teams are more innovative and creative, and that enhances your customer engagement, improves growth, and can really give you a competitive advantage in the market. These teams also exhibit improved decision-making and problem-solving. And this really enhances the efficiency and resilience of the team. And so from my experience, when I work with high-performing teams, they're less phased about things that come out of them from the blue. They seem to be able to handle that and work through sort of unplanned things better than low-performing teams. They just seem to be more in control of situations. And then finally, there's an overall focus on meeting and exceeding customer expectations and a much more of a focus on quality, in my experience, from a high-performing team. And so what that translates to is producing better products and services, which basically delights the customer, and then all the business benefits that come on the back of that. So some of the traits then you see of high-performing teams, and I'm not going to go into each of these in detail. There's a few of them that I want to call out. First one's autonomy and ownership. So we know that high-performing teams have more autonomy and more ownership, and essentially they're more accountable for what they're delivering. They also think about the big picture more. So as an example, and kind of touching a little bit on what Matt will go into next, they don't just think about a product they're building. They also think about how the cloud costs would feed into it as well. So they're factoring all those things up front. They're not kind of dividing that away from their thinking. They're thinking about all these things together. They sort of have that context to make decisions on their own. One thing we've seen in a few of our clients is they've introduced something like the Google's 80-20 rule. And that's where 20% of the time the team spends can be done what they deem important and necessary. And so sort of touching on some stuff Eric said, they'll work on reducing some tech debt to increase productivity. They might do some proof of concepts and new technology in order to see if they can move the product forward. They might do some work to try to reduce cloud costs. Another really important point that I've seen in high-performing teams, or traits that I've seen in high-performing teams, is that real continuous improvement mentality and a testing mindset. And so by that I mean, the team is constantly trying to do things better, regular retros, reflecting on what's working and what's not. And with a testing mindset, they're really thinking about testing up front so they can, whatever they're designing and building can be tested easily and automated, and they can really move more quickly. I worked with a client a while ago, and we really had that trait in, quite strongly. And we're getting to a point where we're releasing to production very quickly with regular small releases. And we were delivering very quickly feature enhancements, but also we had very low bug count and incidents. So and I believe a lot of that was to do with that continuous improvement and testing mindset. And another thing, anyone who knows me will know, I always talk about momentum when I'm working with a team. I feel like it's such an important thing. If a team has lots of interruptions, it's really hard for a dev to work on a complex issue if they've got interruptions all over the place, or if they have meetings sporadically throughout the day. It's really hard to work on something. You've got a 30-minute block here, an hour there. So I would really look to make sure that, firstly, that outside interruptions are kept to a minimal. And if there are meetings, and there's usually cadence type meetings in any team, try to do them early in the morning so the team can then just get on and have plenty of time to work on it. And yeah, work on more important things. Obviously, having a shared purpose and alignment is always important, and everyone in the team is working towards common goals which align to your organization's objectives. So let's talk about measuring performance. There is a bit of controversy in, I guess, the industry around measuring developer performance as opposed to team performance. In fact, last year, McKinsey released a report claiming that they had developed an approach that you could measure individual developer productivity, and that's what, you should go and follow their process or their way of doing it. I would say that report was aimed more at non-technical executives and CEOs who don't really understand why you can't measure a developer like you can a salesperson or a recruiter. It's kind of easier to see how a particular person is performing. So that was quite controversial in that in the development, work is much more team orientated. It's less individual. And so focusing on some of those individual traits can actually have, individual performance can actually have some unexpected or unwanted consequences. So at DS, next slide, please. We preference team over individual product metrics. For that exact reason, it is more of a team work as opposed to some of those other areas I spoke about earlier. And with individual product metrics, sometimes what we've seen and some of the things being done, it can kind of be looking at more effort rather than impact and outcome. And that's not necessarily going to make things better. So I would also say that one thing I've seen throughout my career is sometimes management can get fixated on one particular metric like velocity. That's a bit dangerous because it's firstly, developers can easily, once they realize that they're being marked on that, they can change a story points from 3 to 5, and you're not really getting any improved outcome. So you really need to have a well-rounded number of metrics, and Eric touched on a few of those as well when he spoke. And I guess all of this means that one thing you have to be really careful about when you're measuring behavior at a team level is that measurement shapes behaviors and they come with trade-offs. So you do really need to be aware of what you're measuring and what might be the impacts, because sometimes there's consequences that you don't realize. So you really need to just think it through and work out what you're trying to achieve and set those measurements up accordingly. So in saying that, what we generally do is come up with using, I'm not going to go through each of these lists, and Eric did mention a couple of them already, but these are the kind of metrics that we would look to implement and pull from. And this gives you a well-rounded view of technical output, productivity, and team well-being. So, next slide, yeah. So just to be wary of some additional influences on team performance, Eric's already covered the first, technical debt. I would say is make sure you have a strategy, use some of the stuff that Eric came to, but it does impact productivity. The second one maybe is not mentioned as much, but I have seen this, and I've seen this recently, where organizational culture can impact team performance. So it doesn't matter how good your team is, but if your org has got a poor culture, it does start to bleed in, and it does start to impact the ways of working of that team. It's a harder one to manage because obviously a team can't necessarily change the culture of the whole org. So I guess trying to shield the team as much as possible is what you try to do. But you just need to be aware of that and the impact it has on the team and sort of try to manage it as best you can. Okay, so how building a high-performing team. So where would I start if I sort of came along a team that wasn't performing as well as we'd like? Well, I guess the first point is to introduce changes gradually. You're not going to go from a low-performing team to a high-performing team overnight. It is going to take time, and it's going to take some incremental steps. So what I would suggest is pick a few things, bring them into the team, get them bed down with the team, see how they're working, and then introduce more. If you try to flood the team with lots of changes, and I've seen this go pear-shaped, the team doesn't necessarily know what changes are having what effect, and it doesn't necessarily give you the outcome. They don't necessarily believe in it, and you don't get the outcome that you're expecting. The next one is dev practices. So if you do have poor dev practices, I would really be trying to emphasize making improvements there. So, do you have CI/CD? Are you writing tests? Because I know that those things are sort of stuff that will help you bring quality and confidence. And so they are really fundamental areas, a really good baseline to start with by introducing those dev best practices. You need to define your ways of working. And as an example, have a clear definition of done. So everyone on the team should know what it means to move a card to done. And not just within the team, anyone outside the team should know that when you move something through to done, these are all the things that go with it, such as documentation or whatever you decide it may be. Obviously, I've just spoke about metrics, but if you want to improve, you do need to sort of have some level of tracking and metrics to review. So you need to set that up. And I guess finally, if you're in a leadership position, you need to lead by example. So you need to demonstrate behaviors and practices you expect from your team and let them follow that example. So yeah, in saying that, I'll pass you over to Matt.
Cool. Thanks, Dan. Hi, everyone. So I'm Matt Carries. I'm a principal consultant with DS with over 15 years experience under my belt. Part of my role is helping clients help architects and build their products on the cloud. And lately I've been sort of more focused on the fintech side of space. I'm very passionate about all things cloud. I've got lots of certifications under my belt as well. But main thing is making sure our clients can really make the most of these platforms and support their business. As Dan alluded to, metrics are a major component to anything in terms of measuring how things are going, and cloud costs are no exception. It's important to recognize that costs can really spiral out of control if you're not monitoring them properly and without having the right practices in place. So for many of our engagements, we help clients make the most sense of their costs, understand how that happened, and also provide solution strategies to help get that under control. So today's landscape's shifted a lot recently. So instead of just hosting web applications and customer data, we've seen a lot of innovation in the Gen AI space, but also like machine learning and edge computing as well. This expansion really means that we need to be really mindful of how we actually approach optimizing costs on the cloud, but also making sure that we're putting the right things there as well. So 30% of cloud spend for most organizations is wasted. So there's been quite a few studies on this. Just a recent one by Cloud Zero really highlighted that for most of these organizations, these costs can be easily fixed by looking at how they're actually spending their money. From my experience, in particular, this comes from having a lot of compute resources running idle when they don't need to be, over-provisioned infrastructure, having applications running on a compute that's way over specced for what it should be. But also a lot of legacy applications have been quickly lifted and shifted onto the cloud without really making the most of that platform for manageability side of things as well. These are a lot of real simple things that most organizations are aware of, but you can actually tackle them in a few simple steps as well. For a lot of our work from clients, we've recognized that having a proper strategy in place can help have cost reductions almost immediately by just doing a few simple actions. For example, making sure that instances are the right size. A lot of cloud platforms have automated tools to actually recommend if you've over-provisioned infrastructure that could be scaled down. Automatically shutting down instances that are not running, especially in things like non-production environments during outside business hours, sorry. But also, a lot of cloud platforms offer committed use discounts. So if you commit to spending annually or even like 3 years of spending, that can significantly reduce your cloud expenses as well. But understanding how much you need to pay for in advance is where metrics really come into play as well. But it's not just about optimizing for costs either. It's really making the cloud work better for you. And that means you can invest more smartly inside your business practices. When you do it right, it really helps free up the budget. So you can reinvest that into innovation initiatives, ensuring that you've got the resources for all the teams to help make sure they build the right products and make sure they scale for customer demand effectively as well. Moving on, one of my favorite frameworks, sorry, next slide. One of my favorite frameworks that's really been taking the space by storm is FinOps. It's basically a foundation that helps clients understand their cloud costs, and many large organizations are now implementing this today. Those are just some principles that the actual framework helps basically standardize. It's essentially a cultural practice and operational framework that really helps bring accountability to teams to understand what their cloud costs are, but also helping observability of those costs as well throughout the business. It really helps lay the foundation for making decision-making around how costs are happening in production, but also when you're about to introduce new services as well. So making sure that you understand what the cost will be from an operational point of view before it's even launched. Really having this framework ingrained in your business can really help make sense of where costs are going, but also it helps everyone understand where costs can be improved as well, not just within solid teams if that's happening within your business. So moving on, next slide, thanks. To just reinforce that, you can sort of think of FinOps as sort of a bridge between finance, tech, and the business. So where for many organizations, finance is often siloed and they deal with the costs and not necessarily able to estimate those costs effectively without getting input from engineering teams. Having this sort of foundation helps all layers of the business understand costs rather than having to poke at people to try and work out what's going on. It really helps create a shared language so that way everyone can quickly point at metrics that help influence decisions as well. It also helps understand better resource allocation, knowing that the right teams have the right resources to move effectively and move faster as well. While every team can have their own way of managing resources, you can essentially have your own dedicated FinOps team to help champion these sort of practices and help teams embed these practices within their workflows. This can be some things like making sure that resources tagged appropriately, to having the right appropriate workflows should the costs sort of spiral out of control or a bit higher than expected for different workloads. For example, in the Gen AI space, if using a lot of GPUs, costs can increase pretty significantly if you're not watching yourself. So having this sort of standard practice really helps reduce the risk of having costly mistakes happen from deploying things incorrectly into production or having things turned on all the time without anyone sort of being aware of it. As I alluded to before, you can't really manage what you can't measure. So when we're working with a lot of our clients, we often find that it's one of the sort of things that we point out and that they need to invest more time and effort to actually measure that. A lot of clients are really good at measuring metrics for customer engagement and how customers are using the products, but sometimes you need to also have a look internally in how your business is running day to day. So if we're having a lens on cloud costs, when teams do have a clear visibility in their expenditure in terms of maintaining their products that they own, that can help to affect decisions in terms of architectural uplift, but also, as we alluded to, tech debt, making sure we've got proper investment to fixing systems that need a lot of love and care. For example, developers might choose to run tests on small instances if they find that those instances will help support those workloads, and potentially help architects better storage solutions as well, knowing how storage is being used across the business. Really, what I'm trying to drive here is that having transparent costs across the business really helps everyone understand how they can make an improvement, but also offer suggestions where the business should reinvest internally as well. So doing this sort of framework approach for FinOps can really help prevent exorbitant cloud bills arriving without being aware of that sort of happening in the first place. It helps you really spot potential issues before they arise and get teams sort of acting upon it straight away. Even simple things like setting up alerts for unusual patterns. If certain teams have a common usage pattern for costs, if that blows out by 20%, having the right team alerted by that can help understand if something's gone wrong, but also if there's increased customer demand as well, which might impact that. For example, Black Friday's almost around the corner. That's going to impact a lot of different organizations. So FinOps is not something that happens overnight. It is a fantastic framework, but you need to do baby steps. It's not something you can just jump into blindly. It's a continuous improvement, and having the right team and also people championing that can really drive success for your organization. The next slide, sorry, this is the right slide. No, backwards, sorry. So some common optimization strategies I just wanted to go through. These are sort of ones that we find that we generally adopt for a lot of our clients that come to us wanting to rein in their sort of cloud expenditure. The first one, which is a very large proponent of, is leveraging the actual cloud native architectures that is made available to you. A lot of platforms such as Amazon or AWS, GCP, and Azure have great, highly available systems right underneath the hood, but it means that you need to architect to use those platforms effectively. I alluded to that lifting and shifting legacy solutions doesn't necessarily make the most use of that. So making sure that you can architect using those managed services goes a long way. So that means leveraging things like serverless compute, adopting microservices, and containerization can really help in long ways. So one of the other benefits of this is these sort of managed platforms are also highly resilient, but also very scalable. If you don't really know how much demand you're going to get at certain times of the day, or customer load is very variable, a lot of these platforms scale very quickly and help manage that workload. The biggest benefit in my experience, though, it also helps the engineers sleep at night. Having these sort of managed services means that you can have a lot of these services run without risk of anything going too wrong. And if something does go wrong, it's usually up to the cloud provider's responsibility to help fix that by spinning up more compute or containers to help remediate any failures. For me, this alone is probably the biggest cost savings, because this might mean you don't need to have as many engineers as on-call support, and that alone can save a huge amount of costs. Tagging is another major thing that I'm a big proponent of. You're kind of flying blind if you don't tag your resources properly. So by tagging, I mean things like who's the department that owns the service, what's the project running on, which environment, simple things like that. The important thing to drive home is that consistency is key. You need to make sure if you're using tags that you're using it across the board in a consistent manner. So if you mandate tags on certain resources, even prevent resources from starting in the cloud without those tags, that can make sure you've got clear visibility across the entire stack. And it also helps teams be accountable for what they're spending as well. Next one is avoiding over-provisioning for your services and making sure you can auto-scale as well. In my experience, a lot of developers are happy to write code and deploy it, but not necessarily measure if that's what they're deploying to is the right instance, if it's not serverless. That can really impact costs when you can have a really efficient service, but it's got gigabytes of memory or compute just being wasted because it's not needed. By appropriately analyzing usage patterns, you can really help understand exactly what you need to size instances to. A lot of cloud platforms are also adopting ARM architectures, so like Graviton processors and AWS. In a lot of cases, organizations can use those instances, and if you've got containers and the right architecture in place, you usually can do that overnight and save costs almost immediately. You can think of it like a utility bill. You wouldn't just leave lights on all the time in your house, so you definitely want to turn things off as you're using them. Another optimization strategy that we look at very closely is knowing how your data is being stored in the cloud, but but also if you're making effective use of the different storage tiers. A lot of our clients tend to just use the standard storage tier that all cloud platforms provide, which is great because it's highly available, it's very fast. But for many organizations, they only have the data used maybe for 30 days, and then they might retain it for a few years for archiving. There are intelligent storage products for all the major cloud providers that help basically move data through different tiers, depending how the customers are using it. And that, just doing that on itself, can save costs up to 60% if you've got the right strategy in place. Again, it's just something that helps reinforce that if you understand how your data is being used, there's definitely savings, especially if you're storing terabytes or petabytes of data. And with Gen AI workloads, that's not out of question for a lot of organizations. And lastly, the easiest sort of win as well is just making sure that you actually turn off instances when they're not running. And there's a lot of ways you can actually do that effectively. The biggest one is really non-production. A lot of organizations that we work with tend to have it running 24/7, but for most parts, developers and engineers are only working on those platforms, usually 9 to 5 or standard business hours. We mentioned tagging. You can actually tag your instances to basically have a schedule of when they should be running and have automated workflows in the background to turn those instances off when it's outside those hours. That way you can quickly optimize your costs, but also if you do need developers to boot up an instance because there's a production outage and you just need to test something, you can also have automated workflows to support that as well. So you're not having too many issues there. To wrap things up, I've got a few sort of key takeaways I just wanted to reiterate. The FinOps model, again, it's not something you can do overnight, but it's a fantastic framework to review and just understand where you can actually make a quick impact. The biggest thing for that is observability and transparency, making sure that everyone can view those costs and have that as a discussion point for conversations. It also makes it easier to regularly schedule meetings to work out where optimizations can be made across the different business stacks. It also helps teams own costs. In my experience, having the observability means you usually have someone in your team championing to reduce costs. And that alone is a great thing, and you want to celebrate those wins as well. With the cloud spending efficiencies, again, modernizing applications to leverage cloud native architectures is a fantastic way of doing that. It's not just so much keeping the lights running, but also just, again, having the engineers sleep at night, knowing that all these sort of potential failures that might happen in production can be automatically remediated by the cloud provider in most part. It's also important to understand the usage patterns. And with these metrics, once you have them in play and appropriately observable, helps you make those longer term commitments, understanding how often you should be pre-purchasing compute for a year or even 3 years. That can make it savings of up to 60% in some cases, especially for database scenarios. And lastly, it's really just to drive home that this is a continuous improvement framework that you need to keep in place. It's not something you just do once and then cloud costs are saved. You're always going to have costs there. You just need to have this framework in place to make sure that you can rein in the costs, but also keeps those surprise bills at bay. That's me. I'll hand it back to you, Kirsty.
Great. Thank you. Thank you so much. We've heard a lot from our 3 speakers today, and I'd like to encourage anybody. We do have a few minutes for questions. If you would like to ask questions, the link is in the chat there, and we do have a couple of questions that we'll be asking. But before we do, Erin, if you can go to the next slide, please. We just wanted to get you to give us some feedback on today's webinar. The details are there, so if you could scan the QR code or visit Slido and enter the code there, we would really appreciate you taking a few seconds to rate today's session. Let's give you 30 seconds to do that, and then we'll close. All right, Erin, would you like to move on to the next slide, please? So in closing, we really wanted to hold this session today and talk about this topic because, as I mentioned at the beginning, as we head into next year, planning, people thinking about, what they're going to get done, what budgets they have, what are their priorities. I guess what we're hearing from our clients is the pace of change is faster than ever. And people really feel caught between two imperatives, which is, how do they deliver value from advanced technologies like Gen AI, but at the same time grapple with fundamental foundational challenges that slow progress. So we see this all the time. So that's why we wanted to share these three critical areas that organizations need to get right so that they can build a sustainable foundation for progress. So that's tech debt, which is the hidden obstacle that can stall agility and growth, cloud cost optimization, so balancing that flexibility with financial discipline, and high-performing teams, which is the driving force between lasting change and progress. We feel that these areas are deeply interconnected, and so you need to address them with a balanced approach. And if you do that, it delivers significant business benefits. So you get increased agility. So addressing tech debt and empowering teams creates a development environment where change is seamless rather than disruptive. Teams can iterate quickly, they can adapt to customer needs, and respond to market demands faster. That last one is so key. When you talk about cost efficiency, obviously we want to free up budget previously drained by unmonitored cloud usage. This financial discipline enables organizations to allocate resources to where they're going to drive the most value, such as innovation and strategic projects. And then a balanced approach delivers long-term sustainability. So you have high-performing teams, they maintain a culture of continuous improvement, they address tech debt as it rises, and ensure that cloud costs stay under control. And this sustainability really safeguards the organization's ability to scale and innovate over time. So we really hope today that you've gotten some actionable strategies to align your team, infrastructure, and budget. But we'd love to chat more or come and chat to the teams in your organization about how they can improve in these areas. So we're offering to come and give a focused session with our experts. You can sign up. The details are on the screen right now. But I think probably what we're going to do is take the last few minutes is to answer a couple of questions that have come through. And the first question is for you, Eric. So someone's asked, in particular, you touched on some of the trade-offs. How have you seen teams successfully strike a balance between pushing fast and maintaining long-term growth?
A bit hard to hear the last part, but sorry if it's a bit. Yes, I would say, like we mentioned before, teams tend to know where a problem is, especially if they're reasonably experienced. They tend to know where problems are. So giving them autonomy and time to work out and to improve on what they already know is a problem and trust them to do the right thing is one of them. So not necessarily having to always tell a team what to do, but listening to them and actually let them make some of those decisions themselves. What do we think? What do they think is we think? And so another clear one for me is to try, if you can, to move towards continuous delivery or daytime deployments, because one of the things that really is a problematic with, say, older enterprise systems is you need downtime to deploy. Often happens after hours. So when you have an incident, say during daytime, you may not be able to fix it until nighttime. You can move to the point where you can have zero downtime or low downtime deployments and being able to push through changes that doesn't need big UAT cycles. That would really help. And to do that, again, you need good automated testing. So then really investing in automated testing and trusting the team is probably what I would do.
Yeah, I hope that answers the question. Thank you, Eric. And just quickly, last question. Now, Matt, you actually touched on this in your presentation, but I'll just check to see if you want to add anything more. So someone asked, we're in the process of implementing FinOps, but it's been slow. I'm sure that's no surprise to you, Matt. Any suggestions for getting engineers think more about costs day to day?
Yeah, that's It's an interesting question. Having dashboards that show costs across different teams can help you gamify it in some ways, but you also don't want teams competing with other teams in that way. But that can really make it easier to get recognition for your team that helps reduce costs. For example, when an all hands getting a shout out that teams been able to rein in costs for something that might be quite over the top. For example, a few clients I've worked at, it's normally been things like Datadog or Splunk costs that go over the top. Having visibility that, oh, the way we're logging in our application is actually costing a lot of money, but we're actually logging a lot of redundant data can really help engineers rein in the cost by actually taking the effort to fix that. But also, I'd suggest maybe even thinking like from some of the cost savings, reinvest that back into the team. So many engineering teams sometimes are asking for different training or different opportunities, especially in the Gen AI space. Uh, if you can help teams understand that if they rein in costs, that can essentially get back to them, like the team as well. That could be a good driver to actually help adopt that sort of framework. But as I alluded to in my talk, it's definitely something that you can't jump into straight overnight as a framework. It's definitely like baby steps to get up and running. Because this is key, and just having those like wins as well, like celebrated, go a long way.
Thanks, Matt. That was really helpful. And look, we finished right on time. I wanted to say thank you to everybody who joined us today. We really appreciate you taking the time to spend your lunchtime with us. We really hope that you have gotten some little nuggets to take away, some actionable strategies, and we'll see you at the next one. Thanks. Bye, everyone.